This topic is limits, and specifically we are going to solve one of the more difficult limit problems that you may encounter in homework or perhaps on a test. The problem we're going to solve is the limit as x approaches 1 of the quantity x to the 1/4 power minus 1 divided by the quantity x to the 1/3 power minus 1. Now what's the first thing you do anytime you encounter a limit problem? The answer is you evaluate the limit. What that means is you substitute in for the variable the value of the variable in its limit, in this case 1. So we are going to take x to the 1/4 power minus 1 divided by x to the 1/3 power minus 1 and evaluate it with x equal to 1. The way we indicate that is with a vertical line and writing down x equals 1. So that becomes 1 to the 1/4 power minus 1 and 1 to the 1/3 power minus 1. Well, 1 to any power is 1, so that becomes 1 minus 1 divided by 1 minus 1. And that becomes 0 over 0, which is an indeterminate value. There are only 4 types of values that you can get out of this. One is a number divided by a number, in which case the result of that division is the answer and is the limit of the function. You can get 0 divided by a number, in which case 0 is the answer, and you can get the number divided by 0, in which case plus or minus infinity is the answer, the sign depending on the sign of the number in the numerator. Now, what does it mean when you get 0 over 0? What it means is that you must have a factor in both the numerator and denominator that is causing that. And in this case, that factor must be x minus 1. So in both the numerator and denominator, we're going to find x minus 1 with some remaining expression. It is possible, of course, to have x minus 1 to some power other than 1 in the denominator and also in the numerator. And occasionally what will happen is you will have left an x minus 1 inside these remaining expressions here. In that case, you will find out when you evaluate it at x equals 1 that one of them will be, or maybe even both of them, 0. What we're going to try to do here is to get rid of these factors that are causing the 0 over 0 and then evaluate what is left. That evaluation, if it turns out to be not 0 over 0, produces the answer. The way I like to start this problem is to do a variable substitution. And I'm going to substitute for x y to the 12th power. And the reason I'm going to do that is because it makes the expression more easy to deal with. So substituting, we have y to the 12th raised to the 1/4 power minus 1 divided by y to the 12th raised to the 1/3 power minus 1. What do you do when you have a variable raised to an exponent and then that raised to another exponent? You multiply. So this becomes y to the 12th times 1/4 minus 1 and y to the 12th times 1/3 minus 1. And that becomes y cubed minus 1 over y to the 4th minus 1. So our problem has been changed to this form. The limit as y goes to 1 of y cubed minus 1 divided by y to the 4th minus 1. What we're going to try to do now is we're going to try to factor the numerator and the denominator. So let's write down here y cubed minus 1 divided by y to the 4th minus 1. Well, what do you notice? Well, perhaps you notice that y to the 4th minus 1 is a difference of two squares. Y to the 4th is the square of y squared. So we can write that down as two factors, y squared plus 1 and y squared minus 1. However, y squared minus 1 is also the difference of two squares, and we can write that down as two factors, y plus 1 and y minus 1. Aha! This is one of the factors we're trying to factor out, because that's the only factor here that is going to produce a 0 when y goes to 1. The numerator now is y cubed minus 1, and we need to figure out how to factor that. Well, you might look at polynomial expansions, but also one thing you can do is to divide y minus 1 into y cubed minus 1. Well, y goes into y cubed, y squared times y is y cubed, y squared times minus 1 is minus y squared. And we subtract that. The y cubes drop out, and the result is y squared minus 1. Y into y squared goes y times y is y squared, y times minus 1 is minus y, and we subtract that, and we get the y squared drop out, we get y minus 1. Y goes into y one time, 1 times y is y, 1 times minus 1 is minus 1, and the result of that subtraction is 0. There's a 0 remainder. What does that mean? What it means is that y cubed minus 1 is composed of these two factors. That is, y cubed minus 1 is equal to y minus 1 times y squared plus y plus 1. So we can take this and substitute back into the numerator expression and make it y minus 1, y squared minus y minus 1. And we note that we have a y minus 1 in the numerator and denominator, which are causing the numerator and denominator to be 0, and we can cancel those out. Cancellation is by dividing both the numerator and denominator by y minus 1 and getting a 1 as a result of that. So let's rewrite that function now. As the limit as y goes to 1 of y squared plus y plus 1 divided by y squared plus 1 and y plus 1. This is another problem, another limit problem. What do? You evaluate first. So we take y squared plus y plus 1 divided by y squared plus 1 and y plus 1, and evaluate it at y equals 1. And that equals y1 squared is 1 plus 1 is 3, and y squared plus 1 is 2, and y plus 1 is 2. 2 times 2 is 4, and so that's the answer. Rewrite it in the form of the original problem. It is the limit as x goes to 1 of x to the 1/4 power minus 1 divided by the quantity x to the 1/3 power minus 1, and that is equal to 3/4. And that is the solution to our problem.